example will be left as your homework. Okay, a conical pendulum. And by the way, what is the conical pendulum? A conical pendulum is something like this. Okay. You know, if I have a pendulum like that, if I let it swing back and forth along a line, along a plane, so this is called the Conical pendulum. Okay. If I make it rotate like this is called Conical pendulum. Conical pendulum is if I rotate it like this way. Okay. This is called a conical pendulum. So it forms a cone like that. Okay, the string. And you want to find out in this case, you will find the tension and period. So it's related to how to analyze the system. You can see the ball itself moving along a circle, a horizontal circle like that. So there is a centripetal acceleration like this way. So what I'm saying is that the motion of like this. This is a horizontal surface. So at this point, it must have some centripetal acceleration. And so the force is the tension and the gravitational force. Okay, so you can see if you decompose the tension to this direction, Tx and Ty. So what happens? Ty has to compensate Mg, and Tx has to provide AC, the centripetal acceleration. So with this this kind of analysis, you can find the tension and the period of the circular motion. Okay, so you can finish this problem by yourself. So let's go back to this example. Let's try to get more with that. Okay? I guess I don't have to try to finish it, but let's get more. A conical pendulum. Is something like this. Okay? So we want to find the tension in the string and the period of the motion. So we know that the conical pendulum, the ball, moves with circular motion, okay, a horizontal circular motion. So at any point, it will have the force analysis. At any point, it has two forces. One is the tension T. Another is a gravitational force Mg. Okay. Now we know that again for rotational motion, we have to do the standard procedure analysis. Okay, like here, this is targeting Y. I mean targeting X to this direction. Okay, because I want to match the direction of the centripetal acceleration. Okay. So now if I decompose the tension, I get this is Ty, right? This is Tx, okay? And we can see Tx equals to, what is the angle? 36.9 theta equals to 36.9 degrees. Okay, so this is also theta. So Tx should be sine, T multiplied by sine or cosine? Sine. Okay, make sure you know how to find out if it's sine or cosine. It's opposite to the angle sine. If it's adjacent to the angle cosine, Ty adjacent to the angle, so Ty equals to T multiplied by cosine. Okay. Of course, if you are talking about different angle, you will get different expression. We're talking about this angle theta, 36.9. Now, if you look at the graph, it's very easy to write down the Newton's second law along x direction and y direction. Okay. Along x direction, you get Tx, the only force on acceleration is Tx. Together will give you an Ax, but we know that in this case, Ax is actually AC, this centripetal acceleration. Along y direction, you should have Ty minus mg equals to may, but we know ay in this case should be 0 because it's a horizontal motion. There is no vertical motion, right? So ty equals, ay equals to 0. So ty equals to mg. Now you can see the two equation, if you look at the second equation, okay, you can actually t multiplied by sine theta equals to mv squared over r. The second one should be t multiplied by cosine theta equals to minus mg equals to 0. Okay? So the second equation will immediately give you the tension. Okay, what is the tension in the string? T equals to mg divided by cosine theta, right? So that's part A. Any question here? And once you have tension to plug it here, you can calculate the velocity of the motion, right? So from here, if I plug it in, I get mg over cosine theta multiplied by sine theta equals to mv squared over r, and cancels. Sine theta over cosine theta will give you tangent theta. So v squared, you get v squared equals to gr multiplied by tangent theta, and v equals to square root of gr tangent theta. Okay, so that will give you velocity v. But please note that we want to find the period of the motion. And the period of the motion is related to v, right? The period of motion, of course, related to the velocity of the circular motion. Do you remember how to calculate t in terms of the velocity for the uniform circular motion? You remember that? There is a very simple way to identify this equation. Okay, the equation should be 2 pi r over v, right? Okay. Because v equals to 2 pi r over t. Remember, the velocity can be calculated as circumference divided by period. So of course t equals 2 pi r over v. And here v, we just calculate here, oh by the way, another thing, to get, so v and t, we need to know this, the r here. Both of them have r here, right? What is the radius r here? It's not directly given, but it's easy to calculate. So the r is this, right? This is r. I think it's not directly given, but how do we calculate it? We actually give you the length of the string.
Yeah.
So from the trigonometric function, if this L equals to what's that? 1 meter. So R should be L multiplied by what? Sine theta, right? Look at this triangle. This is the length L. This is the side opposite to it. So it's L multiplied by sine theta. Theta equals 36.9 degrees. So now every information we get it from the problem, so we can plug it in to solve this question. Do you have any question?
What did you get to power?
This is the relationship between the period and velocity. You can go back to check the slide. We have this equation. And if you don't remember it, another simple way you can think about the velocity for a certain motion must be the circumference divided by the period. So of course you can get that one. Okay, another thing I would like to talk about is that the first test is near, I think the next week there. Okay, and please make sure to prepare well for it. Especially, I'm a little bit worried about those who didn't took 1370. Okay, if you took 1370, you kind of have a feeling what's going on. It's just repeat through these stuff. Okay, if you haven't took 1370 before, you will feel that the pace of the class is a little bit too fast. Okay, it is. So you need to spend more time to work out all the problem. Okay. The only way to catch up is to work out all the problem.